Hi everyone. The current unit in our class focuses on calculations with fractions and a few models that you can use to teach fractions to elementary students. One of the more popular models is called the fraction strip. And fraction strips are essentially pieces of paper that are marked into or divided into sections. The strip with no markings is considered the whole or the unit. It's considered one unit. From there, the strips are divided. So this second strip divided into two. Each section of that represents 1/2 of the whole. The third strip divided into thirds is 1/3 of the whole, 1/4, and so on. Fraction strips are particularly useful for teaching the addition of fractions and teaching the addition and subtraction, but also teaching why you need to find common denominators. So we're going to start off with some addition problems where we have the same denominator, so like denominators. In this problem, we are trying to find the sum of 5/7 plus 4/7. So 5/7, if you take the fraction strip divided into sevenths, would be 5 of the 7 pieces of the fraction strip. 4/7 is 4 of the 7 pieces of the fraction strip. Remember, in addition, the addition of numbers is the union of the values of the things representing those numbers. So if I take the union of the 5 strips, or 5 pieces of the 5/7, which takes me to here. Yep, does take me to there. We then find the union, essentially add to that the 4/7, which takes me the rest of the way. When I find the union of those pieces, I get, and I can count them, 9/7. Now, I like to, when I put these together, notice that 9/7 is improper. I mark off, this is the unit, which is 7/7. So 9/7 is equal to 1 unit, or 7/7, plus 2/7 remaining. So as a mixed number, that would be 1 and 2/7. So that's one way you can model addition of fractions with like denominators. Subtraction is very similar. We identify the values that represent the numbers. So 5/7 is 5 out of the 7 pieces. 4/7, 4 out of 7 pieces for the 7th fraction strip. Subtraction with fraction strips utilizes the takeaway model. So if I start out with 5/7, take away 4/7, and a brief interlude here, I think it's important to think about this and encourage your kids to think about this geometrically, or not geometrically, algebraically. 5/7, 5 things. Take away 4/7, 4 things. What are you left with? You're left with 1/7, or 1 thing. Okay, so that's addition with like denominators. How about addition with unlike denominators? And I entitled this slide the problem. So here's the problem when you're trying to add fractions that have unlike denominators. 1/2 and 1/3. The denominators are different. A half is represented by the blue section. 1 out of 2 parts for the fraction strip that's divided in half. Third is the 1/3. When I want to add those, I find the union, I put them together, and I can stack them up. Here's your 1/3, or 1/2, and your 1/3. And the question is, and this is the problem, what does that equal? Well, there's no markup here, right? It's a little bit more than 2/3. Obviously, it's less than 1, but you don't know exactly what it is that 1/2 plus 1/3 equals when you just stack the fraction strips. So here is the solution. What we're going to do is we're going to convert these, and this is why we do this, we're going to convert these numbers to equivalent fractions. And to do so, we need to find the common denominator. Now, it doesn't need to be the least common denominator, but it's helpful. The LCM, which is the LCD, so the LCM of 2 and 3, least common multiple, which is the same as the LCD of those fractions, 1/2 and 1/3, is equal to 6. Okay? So what we're going to do is we're going to convert with equivalent fractions, convert 1/2 to sixths. So what you do with elementary students is line up the fraction bars, but what you also want to do is use equivalent fractions. Use what we know. We know that 1/2, if I want to convert that to sixths, multiply each by 3, and that equals 3/6. Again, when you line these up with fraction strips, you can see that the 1/2 matches the 3/6. For 1/3, we'd convert that using equivalent fractions. 1/3 to get the denominator of 1/6. Multiply the top and the bottom by 2 to create the equivalent fraction. That's 2/6. So I've converted 1/2 is 3/6. 1/3 is 2/6. I want to find the addition of those. Again, you just take the union. 2/6 plus 3/6 equals the total, which is 5/6. So converting these to a common basis allows me to essentially add them and come up with some meaningful unit. Subtraction with unlike denominators works the same way. 1/2 minus 1/3, the difference there, you can actually see the difference is equal to, let me bring up my pen. The difference would be this little piece right there. Think of that as a missing addend. What do you need to add to the smaller piece to get the bigger piece? You need to add that amount. Well, how much is that? Again, we can't tell just by looking at the 1/2 and the 1/3 fraction strip. That's our problem. So convert to a common base, a common unit. Again, the 1/2 equals, as we went through in the last slide, 1/2 equals 3/6. 1/3 equals 2/6. And so modeling this problem, this subtraction problem with fraction strips, we're going to use the takeaway model. We take 3 things, 3/6, take away 2 things, 2/6, and we're left with 1/6. Lastly, I don't want you to leave here. I want you to leave here and leave this video thinking that fraction strips are useful tools for helping elementary students understand fractions. But I don't want you to think that they're a panacea. They're not the solution to all problems. And here's the reason why. As you get numbers that are more complicated, such as this. Now this isn't even that complicated, 7ths and 8ths. So 1/7 plus 3/8. Again, you've got units that are not common. So I need to come up with some units that are common. 7 and 8 being the denominators. So our common denominator, or actually our LCD, least common denominator, is equal to 56. And here is the limitation of fraction strips and many manipulatives. There is no fraction strip that's divided into, oh, excuse me, that's a mistake. I was seeing if you're paying attention. 56. There you go. There's no fraction strip that's divided into 56ths. So the usefulness of fraction strips is limited here. When you get numbers that grow larger, you don't have fraction strips divided into 56 different little pieces. Anyways, this is a useful model. I want you to know how to model addition of fractions with like and unlike denominators with fraction strips.